Another key concept that we will discuss is propagating uncertainties. For this topic, we're going to cover how to determine the uncertainty in a calculated value. First, in addition and subtraction, and second, in multiplication and division. So let's take a moment here. Suppose we want to find the perimeter P of one of the sides of this cardboard. The length is 25 plus minus 1 centimeter, and the width is 10 plus minus 1 centimeter. Given this value of uncertainty, you should understand by now that the 0 in the number 10 here is also significant. Well, the perimeter is just length plus width plus length plus width, which is equal to 70 centimeters. The question now, what about delta P, the uncertainty in the perimeter? This is a rule that can be used to determine uncertainty in addition and subtraction. We'll talk about this rule in a minute, but first, let us just accept and use this statement. If y equals a plus b or y equals a minus b, then the uncertainty in y, which is delta y, is always the sum of the absolute uncertainties delta a plus delta b. According to this, delta p is equal to delta L plus delta W plus delta L plus delta W, and the total is equal to 4 centimeters. Finally, we set the perimeter as P equals 70 plus minus 4 centimeters. Now, this is y. Given this uncertainty in length and width, the length here is between 24 and 26 centimeters. The width is between 9 and 11 centimeters. The smallest perimeter we can get from this information is obtained by calculating the smallest value of the length and the width. And the minimum perimeter in this case is 66 centimeters. The largest value of the perimeter is obtained by calculating the largest value of the length and the width. Therefore, the maximum perimeter is 74 centimeters. From here, using the outer limit of the perimeter, the result is between 66 and 74 centimeters. This implies the uncertainty of 4 centimeters from the calculated value of 70 centimeters. Therefore, the perimeter is quoted as 70 plus minus 4 centimeters. The second case is in multiplication and division. Now imagine this situation. In 14.6 seconds, a car covers a distance of 120 meters. The distance has uncertainty of 5 meters, and the time has uncertainty of 0.1 seconds. The speed is distance over time, 120 meters divided by 14.6 seconds, and this is equal to 8.22 meters per second. The same question as before, what is delta S, the uncertainty in speed? Let us use the previous approach we used for addition and subtraction. In order to get the minimum speed, we should remember this is a fraction. We want the numerator as small as possible and the denominator as large as possible. The minimum speed is therefore obtained by dividing the lowest distance by the largest time. In this case, 115 meters divided by 14.7 seconds, which is equal to 7.82 meters per second. The largest possible speed from this information is obtained by this relation. The largest distance over the lowest time, 125 meters over 14.5 seconds. The result is equal to 8.62 meters per second. Let us pay attention to these values. The speed is 8.22 meters per second, and this is between 7.82 and 8.62 meters per second, which implies an uncertainty of 0.40 meters per second. We then set the speed as s equals 8.22 plus minus 0.40 meters per second. But using this approach can be time-consuming. In IB Physics, as provided in your physics data booklet, we use an approximate method to determine the uncertainty in the calculated results. Consider this data again, in particular, the uncertainties. 0.40 here is no way a result of adding 5 and 0.1, or 5 divided by 0.1, since maybe speed is distance over time. However, when we express the uncertainties in percentage uncertainties, we notice something. The result of adding the percentage uncertainties of the distance and the time, 4.16 and 0.68, the result is 4.84. This value is approximately equal to 4.86, which is the uncertainty of the speed. You might use different examples of multiplication or division, and we guarantee you will arrive at the same conclusion. So in general, if y equals a times b divided by c, then the uncertainty in y is the sum of the fractional or the percentage uncertainties. More precisely, the fractional uncertainty in y is equal to the fractional uncertainty of a plus the fractional uncertainty of b plus the fractional uncertainty of c.